This is SDR News and Geekazine.com's coverage of Microsoft Management Summit, brought to you by HP.
HP Storage Guy Calvin Zito, and we are continuing our coverage at Microsoft Management Summit 2013, and we've moved our way into the Serverquarium. I'm here with Dung Hoang, who is a principal engineer with HP on the Microsoft team. Dung, we did a thing last year here at MMS where you gave me a tour of the Serverquarium, and this is going to be the highlight of the day for me.
Yeah, welcome back, Kevin, to the Serverquarium. So it's a great pleasure for me to show you what we built today, this year, in the Serverquarium. What we call is a real Microsoft private cloud, okay?
Yeah, so let's start with, basically what the Serverquarium is doing is it's running hands-on labs that are over my back shoulder here.
Absolutely, absolutely. As you can see here, we are in the back. We have all the hands-on lab running right now, and I just want to show you what type of labs they are running here from the back wall here. You see an example of some hands-on lab they are running. Most of the hands-on lab are server-based lab, so they are multiple VMs with different requirements in terms of memory, in terms of CPU, etc., etc. So those are very, how to say that, complex type of lab to set up. And this is why we build the hardware to make sure that we can run all those hands-on lab very smoothly.
So as I look at each one of these, each one of these clouds is an individual hands-on lab, and then it talks about the requirements for that lab?
Absolutely, absolutely. So this is just an example of some hands-on lab, right? So, for example, this is a hands-on lab talking about System Center Service Manager. So you can see we have 4 VMs, 1 VM for Active Directory, 1 VM for SCOM, 1 VM for Service Manager. It requires about 15 gigabytes of memory, and in terms of processor, it requires 16 processor, right? And storage 280 gigabytes. Another example of lab is this SP1 Operation Managers integration with Team Foundation Server. It requires 10 gig of RAM and 100 gigabytes. So we need to be very flexible in terms of setup of the lab. It's not just one VM that everyone use, but different type of VMs, right?
And as I look down the wall, most of these have a minimum of 4 VMs, and some of them, like this one here, which is enable secure remote users with remote application dynamic access. This one has 7 VMs.
Absolutely, absolutely. So you see different type of configurations, right? And the other things also very important is that the user have the desktop and they just have a browser. They click on the lab, and we want to make sure that they have the best user experience. That means when they click on the lab, there's a minimal amount time so that we can dynamically create those VM and start them.
So I know last year, I think we broke a record in terms of number of VMs that we ran, and there's still a couple days left here, but where are you at right now in terms of total number of VMs that have been run on our infrastructure?
Oh, that's a very good question. So from Monday to Tuesday, we are about 22,000 VMs for the 2 days, right?
Impressive.
And yesterday at around 2 p.m. we have about 2,200 VM concurrent running across 32 blades.
So 2,200 VMs at once running on this infrastructure?
Absolutely,
wow.
Absolutely. So, and this year we focus more on user experience, right? And also scalability of the types of the lab. Yep. So I want to go back to the user experience. Very important to understand. In average now, when the user start the lab, click on the lab title to start the lab, we are about in average 60 seconds to start all the VM. So from the time they start the lab until the time they can do the hands-on lab, it's 60 seconds.
And so everything gets provisioned on the back end of this infrastructure in 60 seconds for them to start the actual do the lab.
Absolutely, in average, yeah.
Okay, why don't we get a better look at the infrastructure? Why don't you come over here and show me what it is? So tell me a little bit about what we're looking at here.
So what we build here is what we call the HP Cloud solution for Microsoft. So it's really a Microsoft private cloud infrastructure. So what we have here is a fabric, the fabric of compute node, based on compute node, a management node, and a storage node. So let's walk here to talk about the compute node. Okay? So the compute node is is composed of 2 blade system with BL460C Gen A server, 2 proc, and each proc has 8 core. So basically for each blade, we have 16 physical core. And then in terms of memory, we have 256 gigabyte per blade. So we provision enough memory to ensure that we can host a lot of VMs in each blade. Okay, the blade are built as a Hyper-V cluster running Windows Server 2012, the latest operating system from Microsoft, and we have 4 clusters of Hyper-V here. Okay, all the VMs are running on those blades. And then if you go down here, you have a two DL380 Gen A servers, and they are used for the shared infrastructure. So this is where we have all the Active Directory, all the DNS, DHCP, and very importantly, all the Microsoft System Center 2012 SPN product like Virtual Machine Manager, Operation Manager, Orchestrator, Service Manager, in addition with all the HP Inside Control software. Okay?
Well, you know, I didn't get a good look at the front of these until we walked over here, and I expected to see these full. I mean, you're telling me we're running 2,200 concurrent VMs on just a couple of blade systems and a ProLiant server?
Absolutely, absolutely.
That's impressive.
Yeah. And as you can see, there are room to grow. So that means if we have more workload, we can also add more compute node, right? We have enough space for that. Yeah.
And these things look familiar to me. I love the look of those. What do we got 3-par going here with the labs?
Oh, I love the color of the 3-par. It's very impressive, right? And it's in all harmony with the green line of the compute nodes, right? So here we have the enterprise class storage, SAN storage. It's called the HP 3-par StoreServe P10800. So basically, it has all the A controllers here, and all the disk shelf or the cage here.
So it's an 8 node 10,800. That's the controller node, and that's all the storage.
Right. So let me open the door. So as you can see here, we use only 4 node controllers, right? So we can have room to add additional controller if there are more workloads, right? So the nice thing with the 3-par is that all the control are distributed, so support all the I/O hosts. So at the controller level, we already distribute the load. Okay. So here are the disk. So in each disk cage here, we do a multi-tier storage. So we have fiber channels, 15K RPM. We have SAS. 7.2K RPM, and we also have SSD.
Nice.
Right? SSD. So the idea here is that we have multi-tier storage, and with the intelligence built inside the controllers, then the controllers can monitor the workloads, and if there's a workload who requires a lot of I/O, it will dynamically move to the next tier.
So you're using dynamic optimization as a software?
Absolutely, and that is the beauty of that, is that we ensure that we can provide the best performance, the best throughput for the VMs, right?
Yep. Great. So anything else about the infrastructure that you haven't showed us that we really should cover before we?
Oh, I can give you. Sorry, let me close the door. I can give you a very quick walkthrough on how we set it up. It's very important, right?
Okay, let's do that quickly.
Yeah. So as I say here, the management server run SC System Center 2012 Virtual Machine Manager, and we use a feature of SCVMM to do a bare metal deployment of the blade. So we built 32 blades Hyper-V in 1 hour. In 1 hour, just using the ILO, IPMI, and then we deploy that. Okay? And the second thing is, when we build the VM for the hands-on lab, we have also instructor-led hands-on lab in the back. They have 100 seats per room, and each seat requires 10 VM, and they run multiple sessions per day. So during each breakout, we rebuilt 1,000 VM, and the SLA was 10 minutes. And we were able to do that in 8 minutes.
Wow.
And I still have 2 minutes to have a coffee.
You're just standing around here twiddling your thumbs with nothing to do because this stuff's so fast.
Absolutely, absolutely. So let's walk back and see the back plane of that, how we do the connection.
Let's go around the back.
So let's go there. So as you can see here, this is. As you can see here, this is the back plane of the blade system, right? So we have in front 16 blade, and here in the back we use the converged infrastructure device, which is the Vertical Connect Flex Fabric, so that we can mix fiber channel and Ethernet, right? So here I have four fiber channel cables, so I can deliver 32 gigabytes to 16 blade for the fiber channel.
Nice.
Okay. And I take two 10 gig Ethernet, and I
these?
Yeah, the black cable, and I aggregate them. So I deliver 20 gigabits for 16 blade right away. And as you can see, we have a room to grow. So if I need more, I can just put it on.
Yep. Okay.
So let's walk through very quickly. So here from the fiber channel, I go to the SAN switch here. And the SAN switch here go to the disk controller in the back of the tripod. Yep. So this is where we distribute all the workload, all the I/O throughput.
Wow. Well, this is a very impressive infrastructure. I know you've spent a lot of time and effort doing this. This is very impressive, and you're obviously delivering the results that we needed to on the SLAs to power the hands-on lab here. Well done.
Thank you very much, Kevin. Well, thank you.
Thanks for showing us the Serverquarium, and enjoy the rest of Microsoft Management Summit.
Thank you.